Welcome to The Explainer. Today, we are going on a quest. Not for some ancient artifact, but for something way more valuable in the tech world: career success. And your map, your guide to get there, is a rock-solid understanding of networking. This is your CCNA career quest.
So, let me ask you, are you ready to really build your networking career? I mean, whether you're gearing up for that big CCNA exam, or maybe you've got a job interview just around the corner, we're about to break down the core concepts you absolutely positively have to master.
You know, every great quest needs a map, and this is ours. First, we're going to decode the blueprint for networks. Then, we'll get hands-on with building your local network. After that, we'll connect it to the entire world, and finally, we'll learn how to secure the whole thing. So, let's start with that blueprint.
Okay, milestone 1, understanding the blueprint. This is it. This is the foundation for everything. I'm not kidding, everything in networking. From your Wi-Fi at home to a massive corporate data center, it's all built on these core principles. Mastering this, it's totally non-negotiable.
And right here, this is the heart of that blueprint, the OSI model. Just think of it as a 7-layer guide for how all networks are supposed to communicate. Now, for your exam, you have got to know these layers in order. A classic way to remember it is, all people seem to need data processing. Seriously, burn that into your memory. It's your secret weapon for troubleshooting almost any network issue.
Now, this is a classic interview question, so listen up. What's the difference between the OSI and TCP/IP models? Here's how you nail the answer. The 7-layer OSI model, that's the theory. It's the perfect map for learning. But the internet? It actually runs on the more practical 5-layer TCP/IP model. See how it just combines the top 3 OSI layers into one application layer? The takeaway is this: show them you know both. OSI is the why and TCP/IP is the how.
So how does your data actually move through all these layers? It's a process called encapsulation. And honestly, the best way to think about it is like sending a letter. Your data is the letter itself. The transport layer puts it in an envelope, creating a segment. Then the network layer adds the main address on another envelope, making it a packet. And finally, the data link layer puts that in one more envelope with the local delivery info, turning it into a frame. Each layer just wraps it up for the next step of the trip. If you can explain that, you've just mastered a huge networking concept.
Okay, blueprint mastered. The next stage of our quest is to actually start building something. We're going to construct our own local area network, or LAN. This whole section is about the hardware and the rules that let all the devices in one building or one office talk to each other efficiently.
Hub versus switch. You have to know this. A hub is basically a dumb device. It creates one big collision domain, which is a fancy way of saying only one device can talk at a time. It's like a chaotic 4-way intersection with no stop signs, lots of crashes. A switch, on the other hand, is intelligent. It's smart. It creates a separate private lane, a collision domain, for every single port. The bottom line? Switches stop the crashes and give everyone their own chunk of bandwidth. That's why hubs are totally obsolete.
So we've got our smart switch, but how do we organize it? We use VLANs, or virtual LANs. And this quote, it says it all. You're literally slicing one physical box into multiple, separate, logical switches. Each VLAN is like its own little bubble. So the folks in the sales VLAN can't just talk to the accounting VLAN, not without a router controlling that traffic. This is a huge tool for security and for keeping the network organized.
Now, as network engineers, we love having backup paths, right? Redundancy's good. But at layer 2, if you just plug in extra cables between switches, you create a loop. And a loop is a total catastrophe. Without some kind of control, you get these 3 network-killing disasters. Broadcast storms will eat up all your bandwidth. Your switch's brain, its MAC address table, will go completely haywire. And your poor computer will get hammered with multiple copies of the same thing. Spanning Tree Protocol, or STP, is the hero that swoops in to save the day. It smartly blocks the backup paths to prevent any loops, but it keeps them on standby, ready to take over if the main link ever fails. Explaining why you need STP is a fantastic interview answer.
All right, our local network is built. It's stable, it's resilient. But right now, it's basically an island. The next stage of our quest is to build the bridge that connects this LAN to the rest of the world. And that means we're diving straight into the heart of the internet, IP addressing, and routing.
Okay, so inside our private little network, we can't just make up IP addresses. We have to use special private ranges. You've definitely seen these, like 192.168.1.1 on your home router. They were created to save the very limited number of public IPv4 addresses. But here's the catch, and it's a big one. These private IPs are completely forbidden on the public internet. Internet routers are trained to drop them on site. So, how do our devices get online?
The answer, the magic trick, use Network Address Translation, or NAT. This is what lets 100 devices in an office all share one single public IP address to get online. When your computer sends traffic out to the internet, your router translates its private IP address into the public one. It keeps a little note of who asked for what, so when the reply comes back, it knows exactly which computer to send it to. Job focus. You will be asked about NAT. You've got to master this.
Okay, stop. Pay close attention here. Screenshot this slide. This table is pure exam gold. If a router learns about 2 different ways to get to the same place, how does it choose? It uses administrative distance, or AD. Think of it as a trustworthiness score. The lower the AD value, the more the router trusts the information. A directly connected network is a perfect 0. A static route you typed in yourself is a 1. You get the idea. Memorize these values. This is the very first thing a router looks at to pick the best path.
So for a dynamic protocol like OSPF, how does it find the best path? This quote is the perfect analogy. It builds a complete map of the entire network. You see, older protocols kind of relied on routing by rumor, just trusting what their next-door neighbor told them. OSPF is different. It gives every single router a full roadmap of the whole network. And with that complete picture, each router can independently calculate the absolute best, fastest, loop-free path to get anywhere. It's just smarter.
We've built our network. We've connected it to the world. But our quest is not over. Not even close. In today's world, an unsecured network is a massive liability. So our final milestone is to lock down the most vulnerable part of any modern network, the wireless LAN. This isn't just a good idea. It's absolutely essential.
You need to know this timeline cold. This is critical knowledge for any networking job. WEP and WPA, they're completely broken. Don't use them. If you see them on a network, your first recommendation has to be upgrade immediately. WPA2 was the standard for years. It uses solid encryption, and it's still considered okay. But the gold standard today, the best and most secure choice, is WPA3. Let's dig into why.
So what's the big deal with WPA3? Well, it's 2 things. First, it uses stronger encryption, which is great. But the real game changer is a new method called SAE, or Simultaneous Authentication of Equals. This directly protects against a huge weakness in WPA2, what's called an offline dictionary attack. That's where a hacker could just grab some of your encrypted data and then go try to crack your password on their own time. WPA3's SAE makes that kind of attack way, way harder. It is a massive leap forward for Wi-Fi security.
And there you have it. The blueprints, the building blocks, how to connect to the world, and how to secure it all. We've just journeyed through the absolute core of the CCNA. But look, this explainer isn't just about passing a test. It's about giving you the knowledge you need to walk into a room and be a confident, competent network professional. So the final question? That one's for you. You have the blueprint. What will you build?